Universities hire researchers to make scientific breakthroughs. But once the data is collected, the work of communicating those discoveries often grinds to a halt. The bulk of a researcher's time is swallowed up by the tedious process of formatting documents. Look at this data visualization from a recent time audit conducted by a Yale researcher. The hours spent on actual scientific writing are completely dwarfed by the months lost entirely to LaTex syntax, citation management, and margin adjustments. The drain happens in the details. Managing cross-references, emailing file versions back and forth, and hunting down missing brackets to fix compiler errors feels like watching a stack of physical documents collapsing under its own weight. It consumes hundreds of hours. The friction of the writing environment itself has become the primary bottleneck slowing down actual scientific discovery. The cloud editors that dominated 2024 and 2025 provided a shared workspace but remained entirely passive. They required manual heavy lifting for every citation, every table, and every line of code. This logic flow shows what happens when researchers try to plug that efficiency gap with consumer AI. A prompt goes in, and the pathway splits into two failed outcomes, either a broken syntax error that fails to compile, or a completely fabricated citation. To avoid those errors, researchers are forced to fragment their workflow across 3 or 4 different browser tabs, bouncing between a reference manager, a plain text editor, and external chatbots. In a publishing environment where speed determines funding, relying on manual formatting or consumer-grade AI creates severe delays and risks the credibility of the research. By 2026, the standard shifted. Bibby AI moved the industry away from passive text editors and introduced an active, context-aware co-author environment. The platform runs on Gemini 3.1 Pro, but the model has been explicitly fine-tuned. Like geometric shapes locking together into a perfect structure, the AI natively understands academic research arguments and strict LaTeX conventions. This bar chart tracks compiler error detection on the LaTeX Bench 500 benchmark. Bibby AI catches 91.4% of errors, outperforming Overleaf and OpenAI Prism. Instead of cryptic logs, Bibby translates errors to plain English, and auto-resolve's architecture flowchart shows how accuracy is maintained. The system splits incoming reference papers into 3 distinct databases: text, references, and figures. By forcing the LLM to pull exclusively from a dedicated reference database, the system prevents hallucinations and maintains strict citation integrity. Structuring the data retrieval this way eliminates the most manual, error-prone phase of academic writing, guaranteeing that every claim is backed by a real, traceable source. The automation extends to the visual components of a paper. A built-in feature called Paper Banana allows users to generate complex academic diagrams without writing a single line of code. If a researcher sketches an equation on a whiteboard, they can simply snap a photo. The editor reads the handwriting and translates it directly into functional LaTeX formatting. When the draft is complete, a one-click formatting system instantly conforms the entire document to any of the 2,000 publisher-approved templates, whether it's for Nature or IEEE. Before submitting, the AI paper reviewer scores the manuscript. It evaluates novelty, assesses overall clarity, and technical quality, based on specific standards of target venues like NeurETS or CVPR, offering actionable feedback. These automated features compress the final stages of manuscript preparation, handling formatting and review loops that typically take days in a single coordinated workflow. As you can see in this interface design, the ecosystem extends beyond the PDF document itself. The platform can generate and maintain centralized, highly professional websites for academic labs to host their portfolios. The Yale audit revealed months lost to administrative friction. By applying these specialized AI systems, that deficit is replaced by an average return of 40 hours saved per individual paper. Automating both the internal drafting process and the public-facing lab profile ensures that a research group can maintain visibility and professional impact without pulling time away from the bench. In an environment where the rate of publication is often tied directly to funding cycles, saving 40 hours on every paper changes how many projects a single lab can realistically complete and publish. And because the platform operates on institutional-grade privacy guardrails, a lab's unpublished research data is strictly protected. It is never fed back into external models for training. When a secure AI co-author handles the formatting and syntax, researchers get back the time they need to focus on their primary data and their peer-reviewed arguments. Equip your lab with Bibby AI and start writing.